Welcome to Calculus 30. Today we are going to begin Unit Number 1, titled Background Essentials. In today's lesson, we are going to learn about interval notation. Interval notation is a way of writing a certain domain for a particular function. Instead of using inequality symbols or a number line, we are going to use interval notation to record our domain. Now, what do we mean by interval notation? Let's say, for example, we solve the inequality negative 3x plus 4 greater than 10. If we did our mathematics correctly, we would end up with the answer x is less than negative 2. To write this as a solution set, we would write a parentheses x colon x less than negative 2. And the colon stands for such that. Now, it is just as easy to say x is less than negative 2, but sometimes mathematicians want to be very exact and they like to write things as a solution set. We could also write this answer or interval using a number line, and our number line would look something like this, with an open circle at negative 2 and shading everything to the left of negative 2, indicating all values of x less than negative 2. A new method, which is probably new to most of you, is using interval notation. Now, interval notation utilizes brackets in order to distinguish a set of x values that we're looking for. So for the interval x less than negative 2, we use a round bracket and we say we're going from negative infinity up to negative 2 with another round bracket. Now, the round bracket indicates we do not include the endpoint. So round brackets mean endpoints are not included. Square brackets, on the other hand, are called closed intervals because in a square bracket we include the endpoints in our answer. So if we looked at the interval given from negative 4 or negative 5 to positive 4 on a number line, it would look like the following. We would have a solid dot at negative 5, a solid dot at 4, and we would shade in the number line all in between. If we used inequality notation, our answer would look like negative 5 less than or x less than or equal to 4. So the less than or equal to sign relates to our square bracket in our interval notation form. As in our introductory example, round brackets are considered open intervals because the solution does not include the endpoints. On a number line, the solution would look like this. There would be an open circle at negative 5, an open circle at 4, and we would shade everything in between, which indicates all x values between negative 5 and positive 4. As an inequality, we would write it as negative 5 less than x less than 4. Just a little bit of math humor. I'll let you read this on your own, and hopefully it makes sense. So, on the given number line, we're asked to draw a graph of the numbers represented by each interval. So if I'm going from 1 to 4, I'm just going to zoom in on my number line here. 1 would be a closed circle, 4 would be an open circle, and we would shade everything in between 1 and 4. Okay, if we were going from negative infinity to 2, as we're doing in question B, our number line would look like the following. We would have an open circle at 2, and we'd be shading everything to the left, and we would have a big solid arrow at the end indicating we're shading everything to the left of 2. Looking at C, we're going from negative 1 to positive 1, and they are closed, so I would be shading from negative 1 with a closed circle to positive 1 with a closed circle, and we'd be shading everything in between. I think you're probably getting the gist of this, but just to finish off, we'll look at question D. And in question D, we're going from negative 3 to 0, and we are not including negative 3, so it'll be an open circle on 3, a closed circle at 0, and we're shading everything in between. All right, In example 2, we're asked to use interval notation to describe the set of numbers shaded on the number line. Now, if this was a question given from our textbook usually wants us to use set interval notation. I really don't care if we use set interval notation. I just want you to be able to use interval notation. So this first one, would be going from square bracket -1 to square bracket +1. Our answer for B would be going from round bracket -1 to infinity. And remember, infinity always has a round bracket because it never has a definite endpoint. Our answer for C would be going from -2 square bracket to 0 with a round bracket, and that would represent the interval notation for our number line in C. Again, another math humor, which was actually cut out from one of the newspapers. Quite funny. All right, 4 ways to say the same thing. Interval notation is right here. Set interval notation, they just write it in this fancy format. I'm not going to make you ever do that, but our textbook sometimes asks for that answer written in that form. So when you look in the answer key, these two really say the same thing. Actually, all 4 say the same thing. This one here is the inequality notation, and this again would be the set inequality notation. Again, I would be expecting you to be able to do A and C. All right, now we want to use interval set notation to represent each of the following. And again, I'm using set interval notation just because our textbook asks for it. So for this particular answer, our solution would be x such that x is an element of, and then we'll use our interval notation. It would be round bracket -9 to 26 with another round bracket, and our parentheses at the end of that. For this guy here, if we're going to write it as interval notation again, I'm going to exclude the set interval notation now. It's just going to be interval notation. This would be square bracket 7 to infinity with a round bracket. For C, they're both included, so it would be square bracket 0 to 14. X less than 8. Again, we're going all the way to negative infinity with a round bracket and 8 with a round bracket. 100 to 110 would be a round bracket on 100 to 110 with a square bracket. Now, from Foundations 30, no longer Math B 30, but if we went back to what we called Foundations 30, you talked about union and intersection. Union is when we take two sets and we combine their elements together. For example, if we had circle A or set A and set B and we asked you to take the union of them, that means we would combine them together and make one big set. Intersection, which is denoted by our, looks like an upside down U, the intersection contains elements which are both in set A and set B. So using interval notation, represent each set of numbers. So when we're doing this, there's a couple of ways we can do this, but the easiest way I find is to do the following. First of all, I'm going to use a number line for my first interval, and my first interval is -6 up to and including 5. So -6 would be an open circle, 5 would be a closed circle, and I'd be shading everything in between. So there would be my red interval. Okay? Now, when we do this interval -2 to +8, what I'm going to do is draw another number line right below the red number line. And when I put my numbers on my blue number line, I'm going to put them on in reference to where my numbers on my red number line are. So for example, -2 falls between -6 and 5, so I'm going to put a -2 here, and it's going to be a square bracket, so it's a closed circle. 8 is beyond 5, and it's an open circle, and I'm looking for everything here. Now, we're looking for the intersection of these two, so if I was to combine these two together and look at the overlap for these two number lines would go from -2 to 5, so therefore my answer is -2 to 5, and they both would have square brackets because negative 2 and 5 belong to both of these sets. Okay, using the same principle, if I was looking at the union of negative infinity to 3 all the way up to 2 to 20, again, I would do my first number line, and this one would be 3 with an open circle, and I'm shading everything to the left. Then, if I do the second interval, which is 2 to 20, this would be, oops, I'm going to undo that, sorry. I should be using a separate number line for the second one. I'm going from 2 with a square bracket all the way up to 20 with a square bracket and everything in between. And again, the notation union means we want to combine these two together. So if I was to slide these two number lines together, it would entail everything in the negative direction up to and including 20. And that would be my final answer. All right, last one. We're asked to solve mentally x squared less than 100 and use interval notation to describe the solution. So if we take a look at x squared less than or equal to 100. Now, we all know if I put a value in for x and square it, that answer is always going to be positive. Okay, because the property of a square makes any number positive. So we could put negative numbers into this inequality to make the statement true. We could also put positive numbers in for x in this inequality to make the statement true. And if we think about it, if I take any number that is smaller than 10 or any number larger than negative 10 and I place it into this inequality, it will make this inequality true. So looking at it from a number line standpoint, if I had negative 10 and positive 10 and I took anything in between here, and so any number in this region plugged in for x, it would make this inequality true. So my answer in interval notation would be negative 10 to positive 10. All right, so we have completed our unit or section, on interval notation. Okay, so you have to be able to decide whether we use round brackets, square brackets, how to bounce back and forth between inequality and interval notation, and also our number line notation as well. So for today's assignment, it's on page 4. It's noted there for you. You can grab a blue calculus textbook that is on the table, and you can start on the assignment. And please leave the blue textbooks on the table and we'll sign them out next week in class. But do your best to try the assigned questions and we'll take up any problems you might have next week. Thank you, and I hope you enjoyed the lesson.